All right, hello everyone. Welcome to Teal Tech Tips and Tricks, or T4. The purpose of this series is to extend our mission to educating the digital forensic community online. My name's Kent and I'm the coordinator for this project, and today's topic is trim on SATA/NVMe, SSDs, and HDDs, how to get evidence instead of zeros. Presentation will be about 20 minutes and we'll have a Q&A afterwards. There'll be a recording afterwards sent to everyone. As you can see, we're on Zoom for T4. Everyone will be muted, so we don't have to deal with managing everyone's audio, but you can ask questions or make comments in the chat. We'll make sure that all questions are answered in the end, but I will interject a question to the speaker if it applies to the portion of the presentation that he's at. So kind of had a last minute switch here. It's not Max from ACE Labs who'll be speaking, but Roman. He is the head of training and technical support. Just a bit about ACE Labs for those of you that don't know. ACE is a trendsetter in professional tool development for the HDD repair and data recovery industries. ACE develops proprietary data recovery technologies and provides customers with the most comprehensive and reliable professional data recovery tools on the market through its PC3000 product line. And without further ado, I would like to introduce Roman.
Hello guys, welcome to our presentation. It's a great pleasure for me to take a part in it. And today we're going to speak about a pretty interesting topic about modern SSD drive and modern hard disk drive with SMR shingled magnetic recording technology. So before we'll start, I'm just going to present myself. My name is Roman Morozov. I am working in ACE Lab almost 10 years, and I am the head of training and technical support. Again, before we will start, I'm going to share with you our schedule for today, because we are going to speak a lot of interesting information about SSDs and hard disk drives. In the beginning, I'm going to tell you just a few things about our company, about ACE Lab. After that, I'm going to speak about some general ideas which we are talking about in digital forensic world, in data recovery world in 2020. After that, I'm going to start to speak about the data deleting in different types of storage devices. And we are going to compare how the data are going to be deleted on a classic hard disk drive, on modern hard disk drive, and on modern SSDs. After that, we will start to speak about the trim command. What is that, how it's working, and how we can bypass the trim erasing on classic hard disk drive, on modern hard disk drive, and on SSDs. And after that, I think that we will have enough time to provide you some answers on your questions. So Q&A session will be in the end of my presentation. A few words about ACE Lab company. So first of all, we have a history because we are 28 years old on the market, and we have almost 120 countries where we sold our products. So we have a lot of customers, almost 17,000 customers in all world, and we communicate with all of them worldwide. So we get a lot of interesting cases from all countries, and of course we provide our tools for these countries, and we stay in cooperation with a huge number of people. Our company was founded in 1992, and right now we provide tools for data recovery from physically damaged drives, all types, including hard disk drive, SSD drives, RAID arrays, servers, digital video registration tool, SSDs, flash drives, and so on. And in the nearest future, we also planning to release a new tool for mobile devices. But today we're going not to speak about mobile phones, not to speak about mobile devices, because we're going to concentrate our attention on HDD and SSDs. And of course, Teal Tech, our partners, we are in cooperation for last 6 years, and Teal Tech help us to sell products, ACE Lab products in North America, and also they help us to provide a training in their well-equipped class, and they provide us a help in a conference, because sometimes one time approximately per 2 years, per 3 years, we organize some conferences in North America where we share our knowledges with our customers who are interested in data recovery, who are interested in forensic recovery, and of course these conferences are pretty interesting for our attendees. And what we can say about modern storage devices, about storage media devices in 2020. Actually, we have some ideas about it. As I said before, we are talking with a huge number of different companies, with a huge number of different customers worldwide. And some of them have some interesting thoughts. And right now we're going to share these thoughts with you. So first of all, some of them think that hard disk drive, classic hard disk drive, are pretty old. And right now they are not popular anymore. And actually, they are not in use. It's outdated technology. And the most interesting information, the most and the largest amount of evidence you can find only in mobile phones and smartphones, because it's the largest treasury of evidence that you can find when you are dealing with some real cases. And also they thought that there is a huge trend of moving all data inside the cloud. And probably after a few years later, everything will be in the cloud. So no classic storage devices like HDD, flash, SSD, everything will be in the cloud systems. But we have our own opinion on it, and we are not agree with all these terms, with all these ideas. Because first of all, hard disk drive are still in use. And if we are talking about the best choice to store the huge amount of data, classic hard disk drive is still the best option for storing a huge amount of information on it. Also, classic hard disk drive, they still under developing, and such large companies as Seagate, like Toshiba, like Hitachi and Western Digital WD drives, they improving the quality of their drive, they improving the internal structure of them, and these drives become faster and faster. For example, right now the modern SMR drives, which were produced by shingled magnetic recording type, they have the same speed of reading and writing as solid state drives 10 years ago. So right now hard disk drive become more and more faster than they were, for example, 5 years or 10 years ago. And of course, classic hard disk drive, it's the only option for and the best option for RAID systems, for digital video registration, for some specific server storage devices, because they can store a huge number of data. They are not very expensive, and of course they are much more stable than SSD drives if we are talking about rewriting procedures. We're going to speak about it later. What we can say about smartphones? Of course, smartphones, they are extremely popular right now, and of course, all digital forensic experts, they are dealing with smartphones every day. But smartphones have some disadvantages, like, for example, a small amount of memory. Of course, if we are talking about the flagship models in 2020, nowadays, of course, most of them have 128 to 156 gigabyte capacity. But if we are talking about real cases, some of the criminals bought their smartphones years ago, and that's why we can say that approximate capacity of the mobile phones is around 32, 64 gigabytes. And of course, this free array is not enough to store a large data inside. That's why if, for example, some criminal decided to expand the memory inside the phone, he can buy a micro SD card, or probably he can buy some space in the cloud storage devices. And we have another idea, is that everything moved to the cloud. But in fact, right now, this trend is rapidly developed, of course, and it's growing up, but we can't say that everything moved to the cloud right now, because internet connection is still a problem in most of the countries around the world. Moreover, there are a lot of problems connected with the price for internet traffic, because sometimes you have to pay a lot of money for just a let's say 2 gigabyte or 5 gigabyte of traffic on your mobile cell phone. And of course, if you are using some cloud servers, you have to weekly or let's say yearly pay for a rent. You have to pay for a fee. And sometimes customers and a normal user, they prefer not to use clouds because it's pretty expensive. You need to subscribe on it, you have to pay some money of it, it's not so convenient. And of course, most of the, let's say, smart criminals, they know that it's not pretty safe to store information inside the cloud, because when you're storing the information inside the cloud, such large servers like Google, they can use this information for educating their neuron machines, their AE, and sometimes this content might be reading, this content might be analyzed. Of course, Google say that they are not going to read any private information, but actually it's not true, because they analyze this information and they use it for advertisement, for some new algorithm of searching and so on. That's why it's not pretty safe to store your data on the cloud. That's why storage devices, the classic storage devices like SSD, like hard disk drive, they still amazingly popular. And we would like to say that in next years, the problem of getting data from these storage devices will be very actual, even for digital forensic experts who dealing with such devices probably not so often. But anyway, if you want to get access to a dozen gigabytes of information which storing on a classic hard disk drive on SSD, you should know all latest features, all latest improvements of the technologies, and you need to be on the edge of technology to understand how these drives are working, what's inside this drive, and how you can get the largest amount of data from these drives. That's why the question is how to extract the data from these drives, how to get the key to this data. And that's why we're going to share our information, our technologies that we researched about modern hard disk drive and SSDs. And we are going to start from deleting information, because you know that when you are deleting something from a common hard disk drive, data is not physically erased. It's still on the hard disk drive. And usually we can use some file carving, some third-party tools to find the deleted data. But if we are talking about solid-state drive, they have absolutely different internal structure. That's why if we delete something, SSD drive erased everything by zeros during 1 or 24 hours, depends on the model. And again, why it happens? Because you know that SSD and hard disk drive, they have different storaging type, different storage system. And they, when you delete something, they do not overwrite everything by zeros. They do not do some overwriting operation. They just overwrite the metadata, some file system files, and some other things. But data still on the drive. You still can use the file carving to find some file headers, to restore some parts of a file system and get the data. But if we are talking about SSD drive, they have absolutely different type of storaging system. And if you delete something, data during 1 or 24 hours started to be just zeros. And why it's happened? Why data covered by zeros when we delete something from SSD? Actually, the same problem is not connected only with solid-state drive. The same problem connected also with mobile phones, because if you delete something, sometimes in most of cases, NAND memory chip, which is located inside, also erase the information. But why solid-state drive do that? Actually, if we are talking about the SSD, we should know how it's working. And you know that all solid-state drives, they are based on the NAND memory chips, NAND flash memory chips. And NAND flash memory chips, they have a contrast and pros. And you know that they have extremely high speed of writing and reading procedure, while they have a pretty slow speed of rewriting. And it's a real problem for SSD manufacturers, because if we will compare how the SSD is writing and reading data, we can find that if the NAND memory chips are absolutely empty, if they don't store any information on it, it will be very fast writing procedure, because we flash the cells amazingly fast. But if we need to write something, we need to erase the data. We need to prepare the data, the cells for writing procedure. And of course, you have to do 2 steps instead of 1. And that's why manufacturers decided to think how they can improve the trim inside their drives. And they start to think how they can improve the speed of writing on the SSD. And they decided to get some information from SSD, collect information about garbage, and erase it in the background. Here is how the trim happens. And developers of SSDs called this command trim, and right now it's used in all types of NAND-based storage systems, like mobile phones, like SSD drives. As I remember, they still not in use in SD cards, micro SD cards, and in a common USB flash sticks and TUM drives. But I think that it's just a question of time. Probably just a little bit later, this problem will also appear on a classic NAND flash memory storage devices, like I said, micro SD, SD, and UFD. So how it's working? When we delete something from operating system tell the SSD controller to erase the information. Controller says, okay, no problem, I'm going to erase the data in the background. And if we'll see how this process is going, we will see that data which is located inside the blocks is marked for erasing. Controller in the background start to erasing procedure, and the problem is that trim command is used in all types of modern operating system. It's supported by default by all SSD drives, and all procedures of trim become performed in the background. We even don't know that controller is doing something because it's doing in the background. So the worst thing is that when we launching some analysis, when we're trying to find out what's going on with the drive, we can find that data become overwritten in the background, even when we starting to search for some evidence on the drive, when we doing some parsing of the content on the SSD. And how we can prevent the erasing of information on the SSD? It's pretty interesting. First of all, we need to understand how the SSD drive is working. And I can say that no matter what type of SSD drive do you have, it might be a SATA drive, it might be NVMe PCI Express drive, it might be Apple SSD drive, no matter what type is it, because all of them have absolutely the same internal structure. They have a controller CPU, they have a RAM chip, and they have a NAND memory chip array. And this NAND memory chip array storing the firmware, the large microcode like operating system for SSDs. And when we launch power supply on the SSD, controller trying to upload the firmware from the NAND memory chips. And if everything goes fine, SSD works pretty good. It provides us full drive capacity. It can provide us full drive ID, so drive works perfectly without any problem. But in this case, you can see that CPU connected to NAND memory chips through several channels, through several lines, through several buses. And controller can do a lot of background operations at the same time. It can write data, erase data, read data, do a lot of operatings at the same time. So trim is one of these background operating, which is always by default switched on the SSD. So how we can bypass it? Let's imagine that trim command was sent by operating system to controller, and controller get this trim command, and he wants to erase the data. What we are going to do in this case? We need to find a special point on the PCB of the SSD drive and short this drive into a safe mode. When we will short the drive into safe mode, controller will block access to NAND memory chips, and it will be impossible for controller to modify the data on the SSD. And here is the example. This is HP SSD with M.2 interface. It's NVMe PCI Express drive. And here we marked some points on the drive PCB, 2 small points that we need to short. After that, when we will put the power supply on the drive and drive will be shorted, we will completely block the access to the NAND, and drive will be in a safe mode. After that, we need to upload a special loader microprogram inside the drive RAM chip. And when we upload the loader microprogram, a lot of background processors become switched off. So what the loader is? Actually, loader is a piece of a microcode. It's a part of SSD drive microcode. And this microcode contains some parts of functionality of the SSD drive. So we can modify this loader. We can switch off all background processors. We can switch off all optimizations tools inside this microcode, and provide access to external drive capacity gain access to advanced SSD technological commands, and we can do a lot of interesting things with the SSD if it's located in, if it's turned into a technological mode. So we take our loader, our modified piece of microprogram, and upload this loader into drive RAM. Drive start to work pretty slowly because it's using just a single channel connection to the NAND memory chips. But at the same time, trim command become disabled. Drive works not so fast, but we can analyze it. We can make a full copy, no matter that it will take probably not just 30 minutes, but 3 hours. Difference is not so huge. But after we do all these operations, it will be possible to unlock the service area. It will be possible to disable the trim command and do a lot of other operations like reading the content from the NAND memory chips without chip off. So we will send a special command to controller to read the data from the NAND. And after that, we can analyze the content, we can parse it, and of course, data will be decrypted because we are reading all data through the controller, and it's pretty good. Also, the main interesting idea and the most useful thing is that we upload loader not on the NAND memory chips. We upload the loader microcode to the RAM chip. And of course, it's absolutely safe to work with the RAM because it's not contains some serious information, some, let's say, if we will modify it, original content on the NAND memory chip will not be changed. So hash sum will be the same, everything will be the same. Now, this is how the loader uploading is working. And this is the way how we can bypass the trim, how we can bypass the background erasing. And of course, if you are working with such SSD drive and you suspect that probably criminal delete something from the SSD, we can provide you some advices. First of all, do not power on your SSD drive, because even if drive is not connected by SATA, but it's connected by power supply line, background analysis is moving on the controller, and controllers do a lot of background operations. Also, don't try to analyze it with just a software tool, because you have to use a special low-level access tools to get access to technological mode and to bypass the trim command. And our company produce such tools. We produce PC4000 Portable, Express, and UDMA, which allow to work with HDD and SSD all types and analyze them, switch them into technological mode, and get access even if trim command has been sent on SSDs. So now let's speak about the trim command on hard disk drive. Actually, you can see that this trim command was found on SSDs, but how it's possible that a classic hard disk drive are using the trim command? We can't say that all hard disk drive are using the trim command, because we can say that only a new SMR drives with shingle magnetic recording are using this way of data rewriting of data. And for last several years, WD company, Western Digital, they release a lot of modifications of Western Digital Red for servers and for DVR, for NAS. They release a lot of WD blue drives, black drives for very fast computers, and all these drives, you can find their names on this web slide. They already contains trim activated. And what is the difference between PMR, classic drive, and SMR drives? Usually, if we are talking about PMR drives, we can find that all data is storing track by track on the platters. And there is a huge difference between, a huge distance between tracks. And all tracks are going to be reading one by one with a distance, linearly. And the sensor which make writing and reading operation have the same size. But of course, manufacturers of SSD, of hard disk drive want to improve the quality of their drive, and they want to improve the capacity of their drives. And one of the way how they can do it, using a special shingle magnetic recording, which allow us to compress the tracks, because the writer sensor is bigger than the reading sensor. And when the head is writing data on the platter, the neighbor tracks become covered by each other. And we get the situation when data become grouped by bands, the group of tracks. and hard disk drives start to write the data by blocks, by bands. The same actually happens with SSD drive, which write the data not file by file or sector by sector. SSD drives write the data block by block. The same things happens with modern SMR drives, which write the data band by band. And of course, the internal structure of the hard disk drive become more and more complex. For example, if we will compare the internal firmware inside the HDD, PMR, and SMR, we can find that in PMR drive, data is going to be written linearly. So we have a translator which knows which sectors are bad. Translator skip these sectors and provide for us, for customers, just a good sectors, and we get LBA, so we can use it. But if we will compare it with SMR drive, we can find that it's much more complex, because SMR drives contain two-level translator. First of them contain information about bad sectors, and another level of translator contain information where these bands, where these tracks were recording, because again, data is not going to be recorded linearly on the platter. Hard disk drive, SMR drive, they write the data band by band, and they can write some information in the beginning of drive, in the end of drive, in the middle of drive, and they can jump between all these records. So SMR drives contains a much more complex internal firmware. And again, first level translator provide only information about bad sectors, while the second level of translator provide information where exactly the data is located. Sometimes second level of translator might become damaged, and drives start to think that this drive is empty, doesn't have any information inside. And here is a pretty interesting thing. Probably you know the Crystal Disk Info software, which provides some information about internal hard disk drive that you connect to your computer. And here is a classic PMR drive. We can see here some parameters of smart. We can see here some other information. And the difference between PRM and SMR drive is in the active trim command, because you can see that on this drive, trim command is available like a feature. And how the trim command is working on SMR drive. First of all, when we do a quick format on WD SMR drive, a trim command goes to HDD and erasing the second level of translator. While we analyze the data, we can return back only zeros. There is no any data, no file headers found. Even if you will do it with the special tools like, I don't know, some other carving file system tools that allows you to find the file headers, you will not going to find anything, because everything will be covered by zeros. And how we can bypass this problem? Actually, you can bypass it if you will switch the drive into technological mode, and you will try to get access by low-level commands, which we are going to send on the HDD. We can try to start read information if we don't have, of course, translator level 2. We can try to read information by physical block addressing. Of course, in this case, information will be mixed a little bit, and we can't get a large file chains. But anyway, even if data has been erased, with other tools it's just impossible to get any file headers, because other tools are reading data LBA by LBA. While with the help of special tool, which allows you to communicate with the drive on the low level, you can try to bypass this problem and read the data by PBA. So with the help of the PBA reading, we get only partial data recovery. Unfortunately, it's impossible to get a large chains of files, because these files will be fragmented. And probably the largest file that you can get will be the same size as a 1 band or 2 band. It's approximately 20-30 megabytes. But again, it's still possible to recover data, even if your drive, if your hard disk drive was under a trim, and if it erase the second level of translator. It's still possible to get the information. And here on the screen, you can see the result of scanning, where we found some good pictures, some parts of file system, some parts of the Word document, and so on. So theoretically, if we will learn more about this problem, it will be possible to write a special software that can, or probably we can improve PC for sound, of course, which will allow us to improve the functionality and connect all disconnected bands all together and restore the length of these bands. And after that, of course, it will be possible to reconstruct the whole image of the drive and get it, even if second level of translator has been erased. So let's summarize all information. Trim is a really problem, not only for SSD drive, but for modern SMR drives too. And as I remember correctly, this problem is not typical only for WD drives, but it's typical also for Toshiba drives and for Seagate drives, which are also a large, which also have a large part of the market right now. And of course, translator, it's a pretty complex microcode, and it might be damaged by itself during the magnet platters degradation. And right now, our company is doing a lot of research, and we just released a solution for these drives, which allows you to read data by PBA. And in nearest future, we are going to release some updates which will allow us to get not just a partial recovery, but a full recovery, even if the second level of translator has been erased. Thank you very much for your attention. Now probably you have some questions for me.
Yeah, thank you, Roman. Yeah, anyone, you can start typing any questions that you may have in the chat. I would just like to really quick just announce that we're going to be having a product demonstration of the PC3000 Portable 3 on Monday. That's going to be June 15th at 12 p.m. Eastern Time. I'm going to just put a link in the chat to that so you can learn just a little bit more about it. And just so you know, it's essentially a hardware software system to recover data logically or from physically damaged SATA, USB hard disk drives, SSDs, and RAID. And it's portable, so you can be able to use it on a desktop computer in your lab or in a laptop. Here's the link. I'm just going to post it here. Or you can use it in standalone mode in your customer's location as well. So again, that's going to be June 15th, Monday at 12 p.m. Eastern Standard Times, in case you want to learn more about that. I'm going to also send a link in an email along with a recording and a presentation, and a recording of this presentation and the slides for this presentation in the email for anyone who signed up. Yeah, and also just announcing that we're going to be cutting back on the frequency of these presentations as well. We were doing once a week, but it will be about once a month, and we're just going to be working on upping the content and the quality of the content as well. And so, yeah, thank you everyone who's been participating so far. So yeah, Roman, are you able to see some of the questions in here?
Yeah, I can see them pretty well. And if you don't mind, I can provide an answer on a couple of them.
Yeah, sure. What do you see this one from Jonathan Kaya? So if I connect the SSD drive onto PC3000, it will automatically block the trim?
Unfortunately, it's not so simple like you think, because first of all, you should find the special points on the PCB. These points are available on all SSD drives, no matter what is the manufacturer is it, what is the model name, what is the capacity, all PCBs, even the MacBook SSD drives, SSD blade from Apple MacBooks, they have a special shorting points that you can short and switch the drive into safe mode to block the access to NAND memory chips. But if you are blocking the access to NAND memory chips, it's still not possible to communicate with the NAND memory where the data is storing. That's why we need a loader. And unfortunately, loader developing, it's a pretty complex operation because we have to find the original firmware of the drive, we have to analyze it, we have to find out which operations this firmware do. And after that, we need to switch off all the background operations like trim, like other things, and so on. After that, it will be possible to work with the drive. That's why we can bypass the trim pretty easily, pretty fast, using PC4000 portable, for example, with SSD, but we are limited by the list of supported drives. Every let's say 2-3 months, our developers release a software update, which brings a new models inside the PC4000. Right now, we support a lot of models by Samsung, by Intel, by Kingston, by Lexar, by some other manufacturers like a SanDisk, and even WD drives, WD SSD drives they supported. But again, everything depends on the model. If it's supported by PC4000 SSD, if it's listed in the list of supported drives, we can successfully bypass the trim. But before, you have to find the shorting points. You need to short them with the tweezers while you make a power supply on. And after that, you can communicate with this drive with PC4000, and don't be afraid that everything will be erased because someone previously deleted the information from the drive.
Okay, we have a lot of questions. Thank you, everyone. This is from Christopher. What is the action of the portable 3000 on the drive? For SSD, you said read-only mode was achieved by shorting a pin.
Again, when you're shorting the pin, you're not going to switch the drive in read-only. You are, let's say, stop communication between controller and NAND memory chips. So you block access to the data area, to the service area. You do the same operation like, for example, you unsolder all NAND memory chips from the SSD. So you block access to NAND memory chip. But after that, you can communicate with the SSD using some special technological command. Actually, during our Monday demonstration, I've got a case SSD drive with M.2 and NVMe interface, and I'm going to show all steps how we can do the connecting the drive, how I need to short it, how I need to upload the loader. All these steps will be demonstrated. I can say that all steps with SSD drive are extremely simple, and you can recover data from such drive within probably 5 or 7 minutes. So the process is amazingly simple. And of course, on Monday, I'm going to show it for you for better understanding the main process steps.
Yeah, this next question is, will the demo show the numbers of files, of recovered files between SMR drive acquired via traditional method versus AceLab's tool? So yeah, just in case that wasn't clear, Roman is going to be speaking on Monday. So this is a good, he's the best person to ask this question.
Unfortunately, our presentation, our demonstration of portable is not include the topic about SMR drive recovery. We are not going to show this information because I think that SMR recovery is a pretty specific information and pretty specific case. And of course, probably later we can make some demonstration, we can show it, we can share it. But during Monday presentation, I'm afraid that this topic will not be covered. We are going to speak about physically damaged hard disk drive, which contains some issues with the heads, how we can bypass the problem with heads inside the HDD without disassembling it, without opening the hermo block inside. We're going to speak about SSD recovery, and we are going to speak about generally about portable tools, about the main features of our new tool. But again, this demo about SMR is not ready yet. But again, if you're interested in it, you can leave your contact. Probably we can provide some additional demo about it.
This is from Jonathan, another one on the AceLab portable. Is it write protected for the source?
Well, yeah, PC4000 portable has a special switcher. If you activate it, all writing procedures will be blocked on the hard disk drive or SSD or any other drive that you plug to portable tool. But we are not going to speak about right now about background preparations, about background operations, because if you will block writing, if you will, let's say, if you will activate write protection on the drive, you will activate write protection by interface. But if we are talking about internal logic of the SSD drives, like for example, when you're working with a trim command, trim will be activated by default. It's not matter do you activate write protection or not, because controller inside the SSD doing the background erasing by itself. It's not connected with write protection or some other things. But again, yeah, PC4000 portable contains a write protector. So if you want to disable all writing procedures to your drive and you want to make sure that during the, for example, HDD analysis, you are not going to write anything on it, it's possible to do.
Okay. Is there a good resource to go to locate the points and to short in order to block the trim command on various devices?
Yes, of course, this information is provided on our blog. You can see some real case video demonstration, but this demonstration telling about the way how you can switch the drive into technological mode. We're not going to discuss about how to bypass trim, because our blog is concentrated on data recovery, not forensic. But again, if you will find our videos on the blog, we can share the link. You will see that we get a lot of videos with the steps how to find the shorting points, how to short the drive, how to switch the drive into safe mode, how to upload the loader. And of course, it means that if you do all these steps, trim command will be deactivated in the background. So yeah.
Okay. Is the time for trim to 0 the content reset when the drive is powered off? For example, if the data was deleted 30 minutes before the drive is powered off, have we still lost those 30 minutes by the time we get to the drive, to the PC3000? Do you understand?
Yes, this is a good question. And unfortunately, if someone deletes something from the SSD, the speed of background erasing depends on the drive manufacturer, on the controller model, or the capacity. And of course, it depends on the number of data that you erase. Unfortunately, we can't exactly tell how much time SSD needs to erase all information from the SSD drive. We approximately say that it takes from 1 hour till 24 hours to erase the data in the background. That's why if, let's say, criminal delete something, it will be much more better if you will disconnect this drive immediately. But if the data was deleted, let's say 2 hours or 5 hours ago or 30 hours ago, or maybe 1 week ago, of course, I'm sure that the data will be gone and it will be impossible to restore it. Every case should be studied, every case should be researched.
What are the 2 pins that need to be shorted named? Are they typically the same 2 pins? Typically one is ground, but what is the other?
Actually, another one is some kind of a bus line from controller to NAND memory chip. If you will short it, it's some kind of a input-output bus line, and if you short it, of course, controller stop reading the contact from the NAND memory chips. Actually, I don't remember how they call it, but again, if this information is important, of course, I can ask our developers, they will tell me. But I'm not sure that this information is pretty important while you're working with SSDs. Again, we have a blog where you can find a lot of pictures about different types of SSD. And there you will find that all solid-state drive, they have a special points. Sometimes they looks like on the drive that I showed before, where there are just a small 2 holes inside the PCB. Sometimes it might be a little bit different situation when the PCB have just a solder, how to say, the places where the resistor should be installed, but there is no resistor on it, or probably there is no capacitor on it. So if you will find these points and you will short them, you will get the same effect. If SSD drive is not known, but let's say it's supported, but it contains some new modification of PCB, usually we ask our customers to send PCB to us, I mean the picture of the PCB to us, and after that our developers can try to research, they can see how the traces go from the controller, and probably we can say that there are some suspects between all point positions, between all holes inside the SSD. So we can approximately say where the shorting points might be, and we can of course tell to our customer where to short the drive. And of course some customers ask us, is it safety to short the drive? I can say yes, because we never get the situation when customer short some other points and drive become burnt, because there is a pretty good protection inside the SSD drive, I mean the electrical protection, and all operations that you are doing, in most of cases, of course, are absolutely safe.
Okay, so that seems like that is all the questions. I'm just going to post a link here to Monday's demo for the Portable 3. That is again at 12 p.m. Eastern Standard Time. Yeah, looks like there's no more questions. Thank you everyone for attending today. Thank you, Roman.
Thank you,
Thank you
guys.
so much for being so generous and for giving us so much good content and being with us on Tips and Tricks. So thank you, everyone. Have a wonderful week, and I will let you know when our next session is. Thank you.
Thank you, guys. Bye.